In this lesson, I'm going to go over how you can use a more advanced technique to solve indefinite integrals. It really involves whenever you're using the chain rule for derivatives. And just to go ahead and show you the general form of this, the integration of f with a function g inside times the derivative of g of x dx. That capital F will be the antiderivative. You can take that with gx plus c. Now really what this is a play off of the chain rule. You know that if you have this, a function inside a function, you have to take the derivative of that function with g of x in it and then the derivative of g of x. So you're really working backwards on this. And if you think about it, it's a little hard to read the let statements, but if you think of g as being the range of that is the answers that you get that will be placed into f, so it becomes the domain of f. So that's why we have to have that interval I and f be continuous on that I, basically because the range of g becomes the domain of f. And then of course you basically have the g being differentiable on the domain. It's something on the AP exam that you're not going to have to worry about too much. Some theorems you do, some you don't. This, you're more interested in just the technique in solving the problems. What I'm basically going to do in this sort of situation is I'm going to change g of x to u, and then we can find the derivative of that and use that with d of x to be du. And if we can simplify the integral into something we can solve in terms of u and du, then we can find the answer to that. So what we do when we make those substitutions, this f of g of x actually becomes f of u, and the derivative of g of x dx becomes du, and that's something that we can handle, with the capital F being the antiderivative of f, and of course plus the constant of integration. So what I'm going to do is just show you a few examples and then give you a list of problems to try for homework. For our first example, we have the integration of the quantity x squared plus 3 raised to the third power times 2x dx. Now, if you think about chain rule, you know to spot chain rule when you see a function inside of some kind of quantity like a power. So that's what you notice here. And I also notice if I were to take the derivative of x squared plus 3, I would get this 2x. So my goal here is to let u be the quantity inside here, x squared plus 3. So when I do that, I automatically have to let du be the derivative of this times dx. So you can let u be whatever you want, but it has to work with this du. Du has to be the derivative of this with a dx in it. So you want to set it up so that it works out this way. Of course, you can't just do any integral this way. It has to be set up in a very specific way in order to use it. But in this case, it works out very nicely. If we let u equal x squared plus 3, the derivative of x squared is 2x, the derivative of 3 is 0, so we're left with 2x. So we can let u equal x squared plus 3, and that will make du equal 2x dx. By doing that, we can change the integration problem into something that we should be able to solve. We can change it to the integration of u cubed du. And we know that we can take this by adding 1 to the exponent and taking the reciprocal of that result beside it as a constant, or coefficient I should say. So you end up with 1/4 u to the 4th plus c. And it all works out nicely. And then of course you have to go back and place x squared plus 3 into u, because the problem actually has x's. So the person's going to want to see it in that format. So you end up getting 1/4 and times the quantity x squared plus 3 raised to the 4th plus the constant of integration. You must remember that constant of integration. We don't know what the constant is, we just know it has to be there. It can be any constant. So please do not forget that. Okay, and of course it's very easy to check yourself. You can just take the derivative of this and see if you end up with what's up here without, of course, the dx. Alright, let's look at another example. Another common chain rule is when we had e to some power and we concentrated on this being 5x. So I'm going to let u equal the 5x. Again, we must take the derivative of that. Notice we end up getting 5dx. Now the 5 is over here on the left, but it's all multiplication, so you can think of it this way. The integral of e to the 5x times 5dx. So you notice that we're going to change this 5x to a u, and then the 5dx becomes du. And we know that the antiderivative of e to the u power is just e to the u power plus a constant of integration. And we make the final step by going back and putting the 5x in for u. So we get an answer of 5 to the ex plus c. Alright, in this example we have, notice, another x outside of that, but if you think about it, x squared plus 1, when you take the derivative of that, is 2x. So we do have a situation here where we don't have the exact thing here, and I did make a mistake. There should be a dx there. Apologize for that. But there is not a 2. But fortunately, the only thing we need is a constant. Now you can't do this with any x's or any functions, because if we could move that out, we just move everything out to begin with. But we can move constants in and out. So what we're going to do is we're going to go ahead and let u be x squared plus 1. The derivative of that would be 2x dx. And to make a 2x here, then we're going to have to bring a 1/2 out here, because 1/2 times 2 is 1. So I have not changed the value of this expression here. I've just changed 1 into 1/2 times 2, but I want the 2 in there, and we have the 1/2 outside. We want to keep the 2 inside that because we want to change that to du, and that's the only way it's going to work. But now that I have the 2x there, I can change x squared plus 1 to u. So I got u squared, and the 2x dx becomes du. Notice that the 1/2 is still outside of the integration symbol. And we can take the antiderivative of u squared. That's going to be 1/3 u to the third. We do have the plus c here, but notice we also have the 1/2. Now remember, this c is sort of a general term. We don't have to worry about multiplying it by 1/2. We don't know what that c is. That's just to tell people there is a constant that could be there. We don't know what it is. But I am going to simplify this just a little bit by taking 1/2 times 1/3, that is 1/6. And then you have x squared plus 1 by the substitution raised to the third plus c. Alright, for the final example, we've got 2x minus 1 raised to the 1/2 power. Now, this time, keep in mind the derivative of 2x minus 1 is 2, so it's okay that we don't have an x out here, but we're going to have something similar to the example up above. We're going to let u equal 2x minus 1. That means du is going to be 2 dx, so we have to put a 2 in here, which means we're going to have to put a 1/2 on the outside. And I did do that. I put 1/2 on the outside. I went ahead and changed this to the 1/2 power. We're used to doing that, and I went ahead and moved the 2 here so you could see where it's going to change to the du. And notice I changed it to u to the 1/2 du. I'm going to use my power rule for integration to add 1 to that and take the reciprocal of 3/2, which is 2/3. So I still have the 1/2 on the outside. 1/2 times the quantity 2/3 u to the 3/2, then plus the constant of integration. I'm going to multiply this to get 2 over 6, and then that simplifies to 1/3. Do the substitution back in. Notice we still have the 3/2 power plus the constant of integration. Now keep in mind, it's not always going to be 1/2 and 2. It could be any constant. You could have to have a 1/4 there and then put a 4 on the outside. Could do different things like that. Also, as you get more used to this process, you may not always have to actually do the substitution of u and du. You may just catch it and be able to solve it. But I do recommend for the time being that you try that. Now what I've done is I've listed a few problems. These problems are in your textbook, So I went ahead and put the numbers beside them, but I know that some of you may not have your textbook during this time, so I decided I would write them out. And if you have any questions, you can send me questions by email, and we'll take care of it from there. So I'll just gradually scroll down.